So this is the first video covering section 15. In this video, we are going to be going over SN1, well, not this video. In this section, we're going to be going over SN1, SN2, E1, E2 reactions. This is probably going to be multiple videos, and I have no idea how long this is going to take because I'm going to take my time because I want to make sure that you understand everything. I think this is a very important section, and I don't think this section, these reactions are hard to understand. I think it's just a lot of information. So you need to make sure you do spend a significant amount of time not just going through these videos, but possibly going through them twice or even 3 times, and then practicing. So I'm just going to try to teach you everything that I know, and we'll just go from there. So first things first, why is it important to learn this topic? First of all, it's going to be important for later reactions that we go over, the reactions that you have to memorize, usually near the end of the year. Because a lot of them have similar mechanisms. But also, these 4 fundamental reactions show the many factors that can contribute to the outcome of a reaction. So for example, you need to be looking at substrate substitution, type of nucleophile. Do I have a nucleophile or base? Is it strong? Is it weak? What's my temperature sometimes? Although we're not going to talk about temperature because it's usually just such a small detail. What's my solvent? What is my leaving group? Lots of different things. And they all contribute. So it's kind of like a puzzle. So hopefully this will be fun. Might not be fun at first, but the good news is I really do think that all of this makes logical sense. So there shouldn't be anything that you're like, I just don't understand why. Everything should have a reasonable answer to the question why. Why is this happening? Why is this way? Okay, so before we jump into it, I want to talk to you about some definitions because I'm going to be using words and you got to know what they mean. All right, so first word is substrate. Right, I already used that word right there. Boom, substrate, substitution. Okay, so what is substrate? All right, well, I Wikipedia'd, I guess I Googled the definition, and I have pretty decent definition. Substrate is the molecule that reacts with a reagent to give a product. Cool. When I think of what a substrate is, my definition in my head is much, I guess, dumbed down. Really, what I think of when I think of a substrate, I think, oh yeah, that's the molecule that we're reacting with. Like that's the molecule that reacts with my nucleophile or my base. Like that's the thing that I'm focused on, and something's going to happen to it, and then it's going to turn into a product. Okay, so that's what I think of, but we can write down their definition because it sounds better. All right, so the molecule. You know what? Maybe we'll use my definition actually. You can always Google this and get the more formal definition. All right, we're going to use my definition. So the molecule that we are interested in. Well, we're not interested. What do I want to say? The molecule basically, it's what turns into the product. And so that's why we're focusing on it, because that's what ends up being the product. Okay, what's the next word we need to know? Well, we need to know what a nucleophile is. I'm worried we're going to run out of room, so let me just make these small. Okay. Next, what is a nucleophile? All right, now anytime I write, I'm trying to like write out a little diagram of what's happening. I like to draw my nucleophile like this. And usually I'll put a negative charge next to it. Because as long as I always draw it that way, I'll have an idea, yes, the nucleophile is negative. And so I've just drawn it that way for so long that now if someone came up to me in the street and they said, is a nucleophile positive or negative? I would say negative without even thinking about it. But if you think about it, you can deduce what it is. So think about the word nucleophile. So a nucleophile, if we break down the word, means nucleus lover. Now in chemistry, what are the components that make up a nucleus? Well, protons and neutrons. Okay, cool. So now that we know that, then what charge does a nucleus have in chemistry? Well, it has a positive charge. So if something is a nucleus lover, then it loves positive charges, right? It just loves those positives. Well, if something loves positives, then that means its charge, its own charge, is what? Positive or negative? Negative, exactly, right? Because remember, opposites attract. So if I love positive, then I must be negative because opposites attract. And so that's kind of the logic of how you could remember, oh yes, nucleophiles are negative-ish, right? But that's not the official definition. The official definition of a nucleus is a molecule that donates a lone pair to form a bond, right? And that's actually, I really like that definition. Straightforward. It's the molecule that has a lone pair and it just goes boop and it donates it to form that bond. So let me just write in that. So the molecule, or I should say a molecule. Right, it's a lone pair of electrons, right? To form. All right, so that's a nucleophile. Nucleophile, all it is it's donating electrons, okay, to form that bond. Oh no. Let's try that again. All right. Okay, next on our list of definitions is electrophile. Okay, so what's an electrophile? Well, we could go through the same process again. Electrophile, if we break down the word, is electron loving. So if a molecule loves electrons and electrons are negatively charged, then it itself must be positively charged. Okay, but so that's the thinking. So whenever I'm drawing, whenever I'm drawing like a diagram out, I have a little thing for electrophile as well. That's how I draw my electrophiles. That way, I'm just primed to know, oh yes, electrophile positive, because I'm so used to seeing this. I draw it every other day, right? But the definition we have for electrophile is a molecule that is an electron pair acceptor, right? It's a lone pair acceptor, right? And that makes sense because the nucleophile donates the lone pair, so the electrophile can accept those electrons. I guess it doesn't have to be a lone pair necessarily, but it usually is because it's usually from the nucleophile, right? Okie dokie. So there we go. So nucleophiles attack electrophiles, right? Remember, negative electrons attack positive. So, okay, what's another word? We need to know, yes. So SN1, SN2, E1, E2, what do these stand for? Well, I feel like I'm going to spoil it because I'm going to talk about it. Well, actually, yes. So the first two that involve the S, and then we've got the E's, okay? So the S reactions are substitution reactions. The E reactions are called elimination reactions, okay? So, I mean, you know, I don't know if chemists are just not very creative or if they're just trying to make their lives easier and students' lives easier by naming things, you know, kind of describing what's happening. So a substitution reaction is when you have a substitution. So what does substitution mean? Well, substitution is basically when you got one thing and then, boop, you substitute it for something, right? And that's really what it is. But let me tell you the definition from Google. So, a reaction where one functional group is switched with another. I mean, it's pretty straightforward. So, let's write in that definition here. So, substitution. A reaction where one functional group is switched with another. Okay, a different functional group. So we just switch functional groups. So far these don't seem too bad. Okie dokie. Boop. Oh no. That didn't work out. Let me try again. This is harder than it looks. You know what? I give up. I'll just leave it. Okay. Next is, of course, what's the definition of elimination? Well, if I use my same hand analogy here, where you got a group, and then, boop, it's gone. It's eliminated. Pew. Okay?
No switch, it's just out of there.
Right, no switch, it's just out of there. Now, when I looked up the definition for elimination, their definition was a reaction where two substituents are removed from a molecule. And technically this is correct, and I like this definition, but if someone walks up to me on the street and they say, you know, how do you define an elimination reaction? I just think of the one functional group is eliminated. Now technically it is two, and we'll talk about that probably in like later videos because we're going to talk about elimination last. Okay, so, you know, don't worry too much about elimination if it doesn't make sense yet, because we will talk about it. But we talk about substitution first, okay? So a reaction where two substituents are removed from the molecule. All right, so I wrote that. That's the official definition, but I'm gonna put a star here and kind of give my own more basic definition, where a functional group is removed. Okay, and technically it is two substituents are removed, but we'll get to that. We'll get to that. What else? Okay, now we're going to talk about what is a base. Now we've already talked about what is a base. You probably were like, Renee, I know what a base is. That's good. So what's the definition of a base? Well, usually in organic chemistry, we're focused on the Bronsted-Lowry bases. So, and this is the same. a base donates, well, I guess if we think about it in terms of a Lewis base, it donates electrons. Okay, or we could think about it in terms of Bronsted-Lowry, where it accepts a proton. But in order to accept that proton, it had to donate electrons to form that bond. And so if we write down the definition of a base in terms of electrons, you might notice that it looks exactly like the nucleophile definition, right? A base donates lone pairs to form a bond, but usually it's to a proton, to a hydrogen. So what happens is a base is just a specific type of nucleophile. So I want to talk about the differences right now before we even start to look at stuff, just so that when we do get into, you know, the depths of what we're going to be talking about through all this, you already know that these are very similar, but they have differences. So a base is a specific type. And we're specifically talking, well, we're specifically talking about Bronsted-Lowry bases still, because we're still focused on the protons. So it's a specific type of nucleophile that forms a bond to a proton. Okay? So, usually, and I'm sure there are probably some examples where this isn't true, but when in terms of SN1, SN2, E1, E2, nucleophiles are negative and they go after positives, but specifically they go after carbons. It's like nucleophile has a type. They like to go after carbons. Bases are negative, but they don't go after carbons, they like to go after protons. Okay, so they do it the same way, just who they're going after is different. Nucleophiles for carbons, bases for protons. Okay, so here is a little gist of kind of the two main categories, substitution reaction and elimination reactions. So here in substitution, we've got X. X means halogen. Well, that's actually not even true. It's just some type of leaving group, and we'll talk about that. But what's going to happen is this X, and we've got a nucleophile here, and they are going to switch spots. Okay, and that's why it's called substitution, because this X, this leaving group, was substituted with a nucleophile. Okay, for elimination, notice we have a base here, not a nucleophile. And remember what I said, bases go after protons. So the base is actually going to grab a proton, then this bond is going to drop down and it will eliminate the leaving group. Okay, so we're going to end up with a double bond here. But remember, this was our leaving group. Did anything replace the leaving group? No, nothing replaced it. Nothing, there's no, functional group that came in and is now on that molecule. It looks as though the leaving group has just left, okay? And this is kind of what I was talking about earlier with the definition for elimination reactions. Oops, where are they? Here they are. Okay, a reaction where two substituents are removed from a molecule, technically a hydrogen and the leaving group are removed, okay? But most, it's called an elimination because our leaving group, which is what we tend to focus on, has left. It hasn't been switched, or anything like that. It just is gone. All right, so we are going to spend some time, well, it's 20 minutes now. So I think this is a good place to stop this video, and we will start the next video going more in depth between looking at the SN2 reaction and the SN1 reaction.